In the aftermath of a hurricane, ensuring the safety and code compliance of temporary electrical installations is critical. The building department traditionally oversees permits and inspections for construction and electrical work. During emergencies, some repairs might be exempt from standard permit requirements. As the situation stabilizes, the building department should reassess the safety of temporary installations and enforce compliance. The Code Compliance Department is responsible for investigating and enforcing code violations. They should collaborate with the building department to ensure temporary installations meet code. This may involve inspections, citations, and required corrective actions. Florida Power and Light, or FPL, is responsible for providing electrical service but does not have the authority to inspect electrical installations. They rely on the Building and Code Compliance departments to ensure safety standards are met before connecting service. Several potential solutions exist. Firstly, the building department should conduct a thorough review of all temporary installations made after the hurricane. They should identify any non-compliant or dangerous conditions and prioritize inspections and enforcement efforts. Secondly, the Building and Code Compliance Department should establish clear lines of communication and protocols for inspecting and enforcing code violations related to temporary installations. Thirdly, the authorities involved should conduct outreach programs to educate homeowners and businesses about the importance of code compliance and the potential hazards of unsafe electrical installations. Fourthly, if necessary, the local or state government may need to consider modifying laws and regulations to clarify responsibility for inspecting and enforcing code compliance for temporary installations after emergencies. It is essential to take a collaborative approach to address safety concerns from temporary installations after a hurricane. By clarifying roles, coordinating efforts, and educating the public, these installations will not become permanent hazards. It is also important to consider the electrical grounding of all electrical equipment. The grounding conductor provides a low impedance path for fault current to return to the source. This is important for the operation of overcurrent protective devices such as circuit breakers and fuses. Without a proper grounding conductor, fault current can take unintended paths, such as through a person's body, which could result in electric shock or electrocution. All electrical equipment should be grounded in accordance with the National Electrical Code, or NEC. The NEC provides detailed requirements for grounding electrical systems and equipment. These requirements are designed to ensure the safety of people and property. In addition to grounding, it is also important to protect electrical circuits with overcurrent protective devices. Overcurrent protective devices such as circuit breakers and fuses are designed to interrupt the flow of current in a circuit when the current exceeds a safe level. This protects electrical equipment and wiring from damage due to overloads and short circuits. Overcurrent protective devices should be sized and installed in accordance with the NEC. The NEC provides detailed requirements for the selection and installation of overcurrent protective devices. It is also important to ensure that all electrical work is performed by qualified electricians. Qualified electricians have the training and experience necessary to install and repair electrical systems safely and correctly. Unqualified individuals should never attempt to perform electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electric shock and other hazards. Always turn off the power to a circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not sure how to perform a particular electrical task, consult a qualified electrician. The NEC is a comprehensive set of standards for electrical safety. It is important to be familiar with the NEC and to follow its requirements when installing and repairing electrical systems. The NEC is updated every 3 years, so it is important to make sure that you are using the latest edition. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. The NFPA also offers a variety of other resources on electrical safety. You can also find information on electrical safety on the internet. However, it is important to make sure that the information you are using is accurate and reliable. Only use information from reputable sources such as the NFPA and other organizations that are dedicated to electrical safety. It is important to take electrical safety seriously. Electrical hazards can cause serious injuries and even death. By following the safety precautions outlined above, you can help to protect yourself and others from electrical hazards. In a scenario presented, the temporary installations may not meet code requirements. Some examples could include improperly sized conductors, lack of overcurrent protection, and missing grounding conductors. It is important to correct these deficiencies as soon as possible to prevent electrical hazards. Here are some specific examples of code violations that may be present in temporary installations. Firstly, improperly sized conductors. The NEC specifies the minimum size of conductors that can be used for different applications. If the conductors are too small, they can overheat and cause a fire. Secondly, lack of overcurrent protection. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of current in a circuit when the current exceeds a safe level. If there is no overcurrent protection, an overload or short circuit can damage electrical equipment and wiring and cause a fire. Thirdly, missing grounding conductors. The grounding conductor provides a low impedance path for fault current to return to the source. If there is no grounding conductor, fault current can take unintended paths, such as through a person's body, which could result in electric shock or electrocution. Fourthly, improper wiring methods. The NEC specifies the approved wiring methods for different applications. If the wiring is not installed in accordance with the NEC, it can be damaged and cause a fire. Fifthly, use of damaged or defective equipment. Damaged or defective electrical equipment can be dangerous and should be replaced immediately. It is important to inspect all electrical equipment regularly for damage. In addition to the above code violations, there may also be other safety hazards present in temporary installations. For example, there may be exposed live parts, which can cause electric shock. There may also be trip hazards, such as cords running across walkways. It is important to identify and correct all safety hazards as soon as possible. The NEC specifies that all electrical work must be performed by qualified electricians. Qualified electricians have the training and experience necessary to install and repair electrical systems safely and correctly. Unqualified individuals should never attempt to perform electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electric shock and other hazards. Always turn off the power to a circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment such as gloves and safety glasses. If you are not sure how to perform a particular electrical task, consult a qualified electrician. The NEC is a comprehensive set of standards for electrical safety. It is important to be familiar with the NEC and to follow its requirements when installing and repairing electrical systems. The NEC is updated every 3 years, so it is important to make sure that you are using the latest edition. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. The NFPA also offers a variety of other resources on electrical safety. You can also find information on electrical safety on the internet. However, it is important to make sure that the information you are using is accurate and reliable. Only use information from reputable sources such as the NFPA and other organizations that are dedicated to electrical safety. When working with electrical systems, it's crucial to understand concepts like voltage drop and conductor ampacity. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or not operate at all. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. Conductor ampacity is the maximum current a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation, and installation conditions. Choosing the right conductor size is essential to prevent overheating and potential fire hazards. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electric shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault, which is a leakage of current to ground. The NEC requires GFCIs in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are designed to protect against fires caused by arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. SIs detect arc faults and quickly interrupt the power, preventing a fire from starting. The NEC requires of SIs in many locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, protect electrical equipment from voltage surges, which are sudden increases in voltage that can damage sensitive electronics. SPD divert the excess voltage to ground, preventing it from reaching the equipment. The NEC recommends SPD for many applications, especially in areas prone to lightning strikes or power grid fluctuations. Understanding the different types of electrical enclosures is also important. Enclosures protect electrical equipment from environmental factors such as dust, moisture, and corrosion. The NEC specifies different types of enclosures for different applications based on the level of protection they provide. For example, an M3R enclosure is suitable for outdoor use and protects against rain, while an M4X enclosure provides protection against corrosion and hose-directed water. Proper labeling of electrical equipment is essential for safety and identification. The NEC requires that all electrical equipment be clearly labeled with its voltage, current, and other important information. This helps electricians and other qualified personnel to safely install, maintain, and repair the equipment. The NEC also requires that electrical panels be labeled to indicate the circuits they serve. When working with electrical equipment, it's important to follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout involves disconnecting the power to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned back on. This ensures that the equipment remains energized while work is being performed. It's also crucial to understand the requirements for working space around electrical equipment. The NEC specifies minimum clearances for working space around electrical panels, switchboards, and other equipment. This provides enough room for electricians to safely work on the equipment. The NEC also requires that the working space be kept clear of obstructions. In addition to the NEC, there are other codes and standards that may apply to electrical installations, such as local building codes and fire codes. It's important to be familiar with all applicable codes and standards to ensure that electrical installations are safe and compliant. Regular electrical inspections are essential for identifying potential hazards and ensuring that electrical systems are in good working order. The NEC recommends that electrical systems be inspected periodically by a qualified electrical inspector. Electrical inspections can help to prevent fires, electric shocks, and other electrical hazards. It's also important to educate yourself about electrical safety. There are many resources available online and in print that can help you learn about electrical hazards and how to prevent them. By taking the time to educate yourself, you can help to protect yourself and your family from electrical dangers. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always follow safety precautions when working with electrical equipment, and never attempt to perform electrical work if you are not qualified.